Our next question is from GATE 2016 Thermodynamics for 2 marks. An ideal gas is adiabatically and irreversibly compressed from 3 bar and 300 Kelvin to 6 bar in a closed system. The work required for the irreversible compression is 1.5 times the work that is required for the reversible compression from the same initial temperature and pressure to the same final pressure. See here, for the same final pressure, right? The molar heat capacity of the gas at constant volume is this, right? Universal gas constant we have given, ratio of the molar heat capacity we have given, the temperature of the gas at the final state, the irreversible compression case is. In the irreversible compression case is. Let's start with the solution. Just see here. Remember this. We will use for adiabatic reversible process. Whenever we have a process with adiabatic reversible process, then we will use these equations like PV to the power gamma. Other equations we have TV to the power gamma minus 1 and TV to the power gamma minus 1 is equal to constant, and we will use one of these adiabatic reversible process equation at 2 points, right? So you can see here T1 to the power gamma 1, P1 to the power gamma minus 1, and this. After rearranging we get this T2 is equal to T1 P2 upon P1 to the power gamma minus 1 upon gamma. We know that gamma is the heat capacity ratio and it is given as 1.277, and we know that P2 is given 6 bar and it is given 3 bar. So from this we get T2 is equal to 348.67 Kelvin. So just note it down. This is the final temperature when we go with the reversible process, but in the question they are asking in the irreversible process, and they have given one more thing. They have given that, so we will check for that. Sorry. Now from first law of thermodynamics we know that delta U is equal to Q minus W. We generally take for adiabatic process Q is equal to 0, so delta U is equal to W in case of adiabatic process, right? And we have given one more thing. We have given W irreversible is equal to 1.5 times of W reversible. They have given in the question, and so I can write it as delta U, right? Since remember one thing, that internal energy, change in internal energy does not depend on the path. It only depends on the initial and final state, not on the path. So you know that W is equals to delta U. We can say W is equal to minus delta U or delta U, whatever you say. So I can write it as NCV T2 dash minus T1 dash. In case of irreversible I got different temperature, and in case of reversible I got final temperature will be different, right? 1.5 into NCV delta T, that is T2 minus T1. It is also a delta U, but in case of reversible it is also a delta U in case of irreversible. So I don't know the T2 dash, I know the T1, that is 300 Kelvin, and I have already calculated it as T2. T2 is 348.67 Kelvin in case of reversible process, right? So minus 300, and I have 1.5. NCV is constant, NCV is same for both, so NCV to NCV will be cancelled out. Finally we get T2 dash is equal to 373 Kelvin. This is the final answer, right? So thank you. Please make sure to like, share and subscribe my channel. Thank you.